So, you got the worksheet for reactions, and hopefully you've attempted to do it uh, using the expanded single replacement and double replacement, where you have to have the word equation, the balance equation, and then for single and double replacement, you have extra things to do. So I actually did these last semester when we were at school. When I remember that was, I think it was actually February 14th was when I did this, Valentine's Day. I did it for my spring class, and I did these on a whiteboard. Remember that thing? That's where I used to do all my lectures. Uh, so I'm just going to use those slides as my background for each one of these, and they might be a little bit out of order. What I'm going to do is the combustion first, the single replacement, and the double replacement reactions. And so hopefully you'll follow them on your sheets and follow along. So let's just get started. And okay, so the first one was okay, first one is combustion of a hexane. Okay, so the word equation is hexane plus oxygen gas yields carbon dioxide and water. And these could be in the gas, so you should say, if you would probably be told that hexane's liquid, oxygen gas, carbon dioxide gas, and water vapor, or liquid water. So we're going to leave the states off of these. I would prefer that you put the states on when you do these. So I'm going to go ahead and do them. So remember the way that I showed you on the video is you start out with your, you can start with your carbons. Okay, so I have 6 carbons here. So put a 1 as your coefficient in front of the alkane. So you have 6 carbons, so you have to put a 6 here. Okay, so your carbons are balanced. And then your hydrogens, you'd have 1 times 14 is 14. So you need 14 over here. So 7 times 2 is 14. Remember, the coefficient times the subscript is how many of that element you have in the equation. All right, so you do your carbons, your hydrogens first, and then we do our oxygens. Okay, so the oxygens for the carbon and hydrogens, you balance them this way, and then for the oxygens you balance them this way. So I'm going to count the oxygens over here. And don't forget, you have 2 sources of an oxygen. So the 6 distributes both to the carbon. So you have 6 carbons, and here you also have 12 carbons. And you put a 7 in front of here, and 7 times 1 is 7. So you have a total of 19. I told you a real quick way to do this is that if you just divide this number by 2, you put that in front. And that'll be how many oxygens? 9.5 times 2 is 19. All right. And remember I said it's okay to have a half. And if you don't like halves, you can multiply everything by 2. So you would get 2, 19, 12, and 14. Okay. Another quick thing is that notice here that the number in front of the water is half the number of the hydrogen. Now that'll only work for combustion of alkanes. Okay, so now let's do one that is not an alkane, but it's still combustion. I don't know what the name of this one is. There's have quite a few names. I just told you to balance it. So again, you just put a 1 in front of the substance, the fuel. Okay, and then you have 4 carbons, so you come over and put a 4 here. Then you have 1 times 10 hydrogens, so you put 5 here. And now you have 10. And then you balance your oxygens. So you count your oxygens over on that product side. 4 times 2 is 8. Okay. 5 times 1 is 5, so you need 13. Now this one's a little tricky. All right. So you need 13 over here. Right. You need 13 oxygens over here. Well, if you look, you already have 1 oxygen. Okay, so you only need 12 right here. So you need only 12 from the O2. So you just divide the 12 by 2 to get 6. All right. Okay, and you'll see that in the next problem as well. Okay, so this is another one just like the last one. So you're going to put a 1 in front of the carbon. So you, in front of the fuel. So you have 5 carbons, so put a 5 here. You have 2 hydrogens, so that'd be, 10 hydrogens, 1 times 10. So 5 times 2 is equal to 1 times 10. Right now, balance your oxygen. So you have 5 times 2 oxygens right here. And you have 5 times 1 oxygen here. So you have a total of 15 oxygens. Well, come over here. Okay, notice that you have 4 here. So we only need 11 here. All right. So you divide 11 by 2 and you get 5.5. All right. Hopefully you got that. See how that works. Okay, so there's your combustion reactions. Now we'll go on to the single replacement. If you have another way to balance these equations, that's fine. I just like using these methods. They're quick, and it also helps you, for every type of equation, type of reaction, there's actually kind of a method to balance the equation. And I think that's kind of interesting. That means there's a general way to balance equations, but it's kind of cool that you can actually figure out specific ways to balance equations. All right, here's the first single replacement. On the sheet, the silver plus potassium nitrate, that doesn't work. Okay, so you have to use the activity series. Remember, the lone metal has to be higher up on the activity series, and it isn't, silver isn't, and so this reaction does not take place, so you don't have to do anything. Right, now the next reaction does take place. Zinc is higher up than silver, so here's the word equation. Solid zinc plus aqueous silver nitrate yields solid silver plus aqueous zinc nitrate. And then what you do is you write out the equation without balancing it. Okay. All right. So Zn plus AgNO3. Get all your formulas right, and then you balance. So the way that I balance this, as I said, usually start from the negative ion, and so you need 2 nitrates. So I put a 2 in front of here. Okay, and then my next step was to put a 2 in front of, second step here, 2 in front of silver, and then I noticed my zincs were okay. All right, so there's a balanced equation. For the next 2 steps, I'm going to leave off the states. All right, so the ionic equation is what it looks like in water. So nothing happens to the zinc, but the silver nitrate splits apart. Okay, and you have 2 of them. So the silver and the nitrate are going to split apart like that, and it's going to do that twice. And so you have 2 Ags and 2 NO3s. Now on the other side of the equation, okay, this is not going to split apart. Okay, notice it has, when the metals are all by themselves, they have no charge and no subscript. That no subscript means 1, not 0. Okay. And then now the zinc nitrate, okay, when you put that in water, is the 2 nitrates split apart from the zinc, and so you end up with 1 zinc and 2 nitrates. Okay, so there's your ionic equation. Right, the net ionic equation cancels out the spectator ions, which is always going to be negative ion for a metal plus ionic compound. And then this is the result of that. All right, and then the half reactions, just look at what happens to each metal. The zinc goes from Zn to Zn2 plus. Okay, so how it got from 2 plus, that means it lost 2 electrons, so it was oxidized. And the silver, each silver started out with a plus charge and ended up losing that plus charge, which means it gained electrons. So actually, each silver gained electrons. See, there's two electrons, one per silver, and then you end up with this. So the silver gained the electrons, so it's reduced. So what happened was the zinc transferred electrons to silver. One thing you'll notice is that the lone metal will get oxidized, and the ionic metal will be reduced. The other thing is a spectator will always be the negative ion. This is for metal. Okay, single replacements. We get the non-metal single replacement. It's kind of the opposite. All right, next problem. Okay, it's kind of hard to see, but we start with aluminum. This reaction takes place. Solid aluminum plus sulfuric acid. All right. What I would suggest is you change the sulfuric acid to its ionic name so you can figure out the names. So what's going to happen is the aluminum is going to take the place of the hydrogen, and hydrogen is going to come off. So you end up with aluminum sulfate plus hydrogen. Okay. Right. And then, so aluminum says Al, no charge, and sulfuric acid is H2SO4, 2 minus. Okay, we're going to write in its ionic form. Okay, so it's H plus, two of them, because there's one plus for every, so there you need two H's for every two minus. Aluminum sulfate is this thing, Al2, SO4, 3, and hydrogen is H2. And then the balanced equation, start with the sulfate. You have three of them, so what you're going to do is come over here and put a 3. Okay, then I'm going to fix my hydrogens. I have 6 hydrogens right here, so I'm going to put a 3 here. 3 times 2 is 6. Okay, and then my aluminums, I have a 2 here, so I need to put a 2 over here. All right, so that's the balanced equation. So start out with usually starting out with the negative ion will lead you to the balancing equations. So I balance the sulfates first, then the hydrogens, and then aluminum. All right, now the ionic equation. So what we have to do is look at what happens. Aluminum, nothing happens to that when you put it in water, but the sulfuric acid splits apart. The 2 H's come off, 2 H pluses come off of the sulfate, and so you have 2 H pluses and sulfate, and that does that 3 times. 1, 2, 3. And so you end up with 1, 2, 3, 4, 5, 6 hydrogens, H pluses, and 1, 2, 3 sulfates. Okay, on the other side, the aluminum sulfate splits apart. All ionic compounds we're saying split apart in the water, so this splits up into the 2Al split up and the sulfate split up, and so you end up with 2 Als and 3 SO4s. Okay, and that's the H2. All right, and this is your ionic equation, and then your net ionic equation cancels out the spectator, which is sulfate, and then this is your net. Okay, and then your half reactions is write out what happened to each metal. Aluminum goes from having no charge to having a 3 plus charge. Okay, so to get a plus charge, that means it got more negative. Became less negative. So each aluminum lost 3 electrons. It did that twice, so there were 6 electrons given off. And the hydrogen, okay, it went from H plus, so there's 6 hydrogens over here, and there's 6 hydrogens over here. So it went from 6 pluses to no pluses. That means it gained electrons, so there's 6 electrons here. Remember, don't bring the 2, but don't put the 2 here and the 2 here. Don't bring down the 2, okay? It's because this splits apart. It splits apart into two H's. This does not split apart. This is a covalent molecule that does not split apart in water. All right, next one. This one is a non-metal single replacement. Okay, first of all, let's see if it works. Okay, for it to work, chlorine, the lone non-metal, has to be higher than the non-metal in the ionic compound. It has to be higher up in the periodic table. And chlorine is, therefore this reaction does take place. Okay, so it's chlorine gas plus aqueous potassium iodide gives me solid iodide. How do you know it's solid? Well, I'd either have to tell you, or if you look at the periodic table, it will tell you it's solid. And aqueous potassium chloride. All right. Then the chemical equation, Cl2. Okay, chlorine is a diatomic. No charge. Okay. When it's all by itself. Now notice the nonmetals have a subscript of 2. All right. And then you have potassium iodide, and I'll explain the balance in a second. Iodide is a diatomic, and then KCl. So I'm going to start out. It doesn't matter where you start. I'm going to, I guess I'll start out with, I have 2 Cl's right here. So that means I need to put a 2 here. Now I have 2 Cl's. Now I have 2 K's, so I put a 2 here. And now I have 2 I's and 2 noses. No. And I have 2 I's here. Right, so this is a balanced equation. Okay, what does it look like in water? Okay, the ionic compounds split apart. Okay, each Ki splits apart, so the Ki, when you put it in water, splits apart into K and I, and does that twice because there's 2 of them. Don't forget the charges. Whoops, that's a minus charge. And then I2, nothing happens to that. And then the potassium chloride splits apart into potassium chloride, and it does that twice for potassium 2K plus 2Cl minuses. All right, now with nonmetals, all right, you'll notice is that the positive ions are the spectators. Okay, and then bring down what you got here. Chlorine plus 2I minus yields I2 and 2Cl minus. All right, and the half reactions, Cl2 goes to 2Cl minus right here. Okay, so it gained 2 electrons. So there's this guy split into 2 Cl's, each one grabbing an electron. And the iodine did the opposite. So each iodine lost an electron, and the 2 iodines came together. And you don't have to know why they come together, but they do. All right, and so you can see that what happens is here that the iodine gives electrons to the chlorine. So in this case, the lone nonmetal becomes reduced, right? Which was the opposite for metal ionic, single replacement, where the lone metal got oxidized. All right, next problem. Okay, this one's a little harder because of what you don't know about water maybe. So you have lithium plus hydrogen, water, and we can write water as hydrogen hydroxide. Okay, and when we do that, it becomes like an acid. Usually, when you have a chemical reaction, as we'll see in our reactions, except for combustion, you can write water as hydrogen hydroxide, H plus O minus. This reaction takes place. Lithium is higher up on the table than hydrogen, because the hydrogen now is behaving like a metal. All right, so this is like this is basically a metal plus an acid. All right, so you have lithium plus HOH, HOH. Then lithium hydroxide LiOH and H2. So it's a balanced equation. So what do we have here? Well, the only thing so everything looks balanced except for your H2s. Okay, so you have two. So one thing you got to be careful of here is this OH is this right here, and these H's are these H's right here. So there's two H's here, so those two H's are right here. Okay. All right. So I put a 2 in front of here so that I have two H's. That's an H plus right there. Okay. Now I need two OHs because I have put a 2H here. All right. And so my second step is to put 2 in front of to get two OHs. And then my third step is to put a 2 in front of the lithium. Right, there's your balanced equation. The ionic equation is what happens with water. So the hydrogen and H plus and the OH minus split apart, and there are two of them. Okay, so they split apart like this over here. So we have your HOH and HOH, and they split apart. Does that twice, excuse me. And the lithium hydroxide splits apart. Each one splitting LiOH, and it does that twice, so you end up with two Li's and two OH minus, and then H2. Okay, what's common on both sides are the OHs, and so this is your net ionic equation. Okay, so just bring down everything except the OHs. Right, the half reactions. So the lithium goes from 2Li to 2Li plus. Okay, that means that it lost, each Li lost electron, so it's 2E minus. And each hydrogen gains electron. Okay. Don't get confused with this part right here, all right? So this is, so you have your H pluses, so you have two H pluses turn into H2. Right, and the way they do that is they gain 2 electrons. So this becomes reduced, the hydrogen becomes reduced. So in metal acids, the hydrogens are always going to be reduced. Okay, copper with iron sulfate, iron 2 sulfate, that's no reaction. That's because copper should be higher up than iron, and it's not, so this reaction doesn't take place. All right, iron with lead nitrate, that reaction takes place. Iron's higher up than lead, so you can just write the rest of the equation. Okay, and I said assume if you don't know the oxidation state of one of the stock metals, use the highest oxidation number, so iron 3. Unless you're told. Okay, so, and then you write iron, then lead nitrate, PbNO3, 2. Lead, iron is FeNO3, 3. And then the balanced equation, start here. Okay, I'm going to start with, well, this one's a little harder. You want to start with your negative ion. So it's not a straight relationship. So you just can't put a 3 in front of here and a, I mean, well, you can. I mean, so it turns out is that what's common, I mean, there's 2 here and 3 here. What's common between the two is 6. So if I put a 3 here, you have 6 nitrates, 3 times 2, and 2 times 3 nitrates, 6. So you have 6 nitrates. All right. And then what you do is just fix your metals. So you have 2 in front of iron, so put a 2 here, and then 3 and a 3 here. Okay. Again, we started out with balance with the nitrates. So this is, so first thing was to get 6 nitrates and then fix your iron and lead. All right. Okay, what happens? The lead nitrate splits into lead and two nitrates, and it does that 3 times. Okay, so you'll end up having 1, 2, 3 leads and 6 nitrates. 1, 2, 3, 4, 5, 6. Okay, on the other side, you will have each iron is split up into iron and 3 nitrates, and it does that twice. So you have 2 irons and 6 nitrates. That should be a 6. 1, 2, 3, 4, 5, 6. Okay, and then the nitrates cancel out, and you end up with the net ionic equation. Okay, and then bring down what happens. So iron goes from no charge to 3 plus charge. So each iron loses 3 electrons, does that twice. So it loses 6 electrons, and it's oxidized. The lead, on the other hand, each lead gains 2 electrons, goes from 2 plus to no charge. So the way it gets more negative. So less positive means more negative, and so it gains 2 electrons and does that 3 times. So it has 6 electrons reduced. Okay, next reaction. Okay, so there's copper with luminous sulfate. So copper is should be higher than aluminum for the reaction to take place. It isn't, so this reaction doesn't take place. Okay, next one. Aluminum plus lead nitrate. This reaction does take place. Aluminum's higher up, so you get lead plus aluminum nitrate. Okay, so you write it out. Al, 0 solid lead nitrate, PbNO3 2, lead, and then Al3NO3, and then the balance equation. Again, just like the last one, you have a 3 here and a 2 here. So what's common both sides? So you just put is 6. So you have 3 here and a 2 here. So now there's 6 nitrates. And then fix your aluminums and your leads. So now you have 2 aluminums here, so put a 2 here. And you have 3 leads here, so put a 3 here. All right. Okay, then your ionic compounds, the lead splits into, each lead nitrate splits into PbNO3. Okay, 2 NO3s and 1 lead, and does that 3 times. So there's 1, 2, 3 leads, and there's 1, 2, 3, 4, 5, 6 nitrates. For aluminum, the aluminum nitrate is AlNO3 3. So each aluminum nitrate splits into aluminum and 3 nitrates, and it does that twice. So you end up with 2 Als and then 6 nitrates. Nitrates cancel out, they're the spectator, and then you have your net. And then your half reactions, Al loses electrons, goes from each Al loses 3 electrons, does that twice, so it loses 6 electrons and it's oxidized. And the lead, each lead picks up 2 electrons, does that 3 times, so this is 2 times 3 times 2. And so so it loses 6 electrons, and that gains 6 electrons. So it's reduced. All right, so this is another single replacement. This time it's a non-metal single replacement. This one here doesn't work because bromine, for it to take place, bromine would have to be higher on the periodic table than chlorine, and it's not. Okay, so this reaction doesn't take place. Next reaction, you have chlorine with sodium iodine. This does take place because chlorine's higher up than iodine. So you're going to start with chlorine gas plus aqueous sodium iodide yields solid iodide. So this, remember, in this case, the nonmetals are swapping places. And you get sodium chloride. All right. I'll write the equation out, each formula, Cl2, no charge. Sodium iodide, Na plus, I minus, I2, no charge, Na plus, Cl minus, then balance the equation. You have two I's, so you put 2 here, and then you have 2 Cl, so you put 2 here, and you balance. Okay, each sodium iodide splits apart, and it does that twice, so you have 2 sodiums and 2 iodines, so you have NaI. Okay, each one splits apart. And so you have 2 NAs, pluses, and 2 I's. Okay, and same thing over here, except chlorine. Again, cross out the positive ion, which is sodium, and that's your spectator. What's left is the 2 nonmetals. And again, the lone nonmetal would be reduced. So what happens to it? It goes from Cl2 to minus, goes from no charge to a minus charge, so it gains 2 electrons. Each chlorine in here gains 1 electron. And each iodine loses an electron. Okay, another single replacement. There's a lot of these, and the reason why I do this is to show you many possibilities as you can have out there that I can think of. Pure permutations, basically, of balancing. Okay. So this reaction will take place. Iron's higher up than silver, so you get solid silver and aqueous iron 3 acetate. So iron, no charge. Silver acetate. Okay, silver and iron acetate. Fe acetate 3. Alright, in the balanced equation, I'm going to start out with my acetate. So I have 3 of them here, so I come over here and put a 3. First step. And then I fix the silvers, so I put a 2 here, a 3. And then lastly, I check my irons and they're okay. Alright, next thing, what happens in water? Well, over here, each silver acetate splits apart in Ag and C2H3O2. Okay, and it does that 3 times, so you end up with 3 Ags. Oops. Okay. 3 Ags, and then 3 acetates. Sorry about that scribble over here. I lost my pen. And what happens to the iron acetate? Well, iron acetate has 3 acetates attached to it. Each acetate splits off, and the iron splits off. So you have iron and then 3 acetates. 1, 2, 3. Okay. So this is your ionic equation. Your net ionic equation loses the acetate, and then you have your net ionic equation. And then you have your half reactions where the iron goes from no charge to 3 plus charge, so that means it lost 3 electrons. And each silver gains 1 electron, so it's reduced. Okay. Next one is non-metal single replacement. This reaction takes place. Bromine's higher up than iodine. So we just go through it same ways. It's just going to be a little bit different. So you have bromine, Br2, no charge. You have calcium 2 plus, I minus 2. Okay, so there's 2 because calcium's 2 plus, and you need 2 I minuses. Okay, it's not I2 minus, it's I minus, so it's not I2 minus, it's I minus 2, okay? Now, you'll notice over here that this is I2 no charge. All right. So that'd be kind of like this guy over here, but I2 0. So be careful about that. I remember getting mixed up about that all the time when these problems. So this I2 is a different why, the reason why this is I2. This is a diatomic version. This is because it balances the charges. All right, so go back to calcium, Ca2 plus I minus 2. And then you have I2 plus, again, same kind of thing over here, calcium 2 plus Br minus 2. All right, and then to balance the equation, how does it look? So you have two I2s, it's already balanced. Everything's balanced already. Okay. Next thing, what happens in water? Okay, the calcium iodide. Okay, so the calcium iodide is there's two iodides attached to one calcium, so they all split apart. Okay, so you end up with one calcium and two iodides. And the same thing with the calcium bromide. There's two bromides attached to each calcium, so they split apart. The calcium and two bromides. Right, spectator ion is going to be the positive ion for nonmetals. And so this is your net ionic equation. Then bring down each one of the nonmetals. So bromine gets reduced. It gains 2 electrons. It goes from no charge to having negative charges. And the iodine goes from having minus charge to no charge. So it loses electrons. All right, another single replacement. Okay, so may get tedious, but just trying to help you out. Okay, so this reaction takes place. Aluminum's higher up in this activity series. So these are your word equation. Okay, so you have aluminum. So to balance the equation, first thing I do, I have 3 sulfates. So I could put a 3 in front of the copper sulfate. So I have 3 sulfates. Now I have 3, so I come over here and put 3 coppers, and then I fix my aluminums, okay, with 2. For first step, so this is the first step. It says 1, my second step, 2, and the third step here. Okay, putting aluminums on. All right, what happens when you put this, each copper sulfate splits apart, okay, and the CuSO4, and it does that 3 times, so you end up with 3 coppers and 3 sulfates. The aluminum sulfate, there's 2 aluminums and 3 sulfates, they all split apart. So you have 2 aluminums and 3 sulfates. Sulfates cancel out. They're the spectator. Okay, then you end up with this as your net ionic equation. And then you have your half reactions. So take a look at that. Make sure you get it. Study as long as you want. Right, next single replacement. Okay, same idea. Okay, so we have iron, copper sulfate, copper, iron sulfate. So I'm going to start out with my sulfates. I have 3 sulfates here, so I put a 3 here. So step 1. And then I need to have 3 coppers, because I have 3 here, so that's my second step. And then my third step is fix my iron, so I put a 3 in front of it. Okay. Right, the copper sulfate split into CuSO4, and you do that 3 times, so you have 3 Cus and 3 sulfates. The iron sulfate, okay, they all split apart. The 2 irons and the sulfates all split apart, so you have 2 irons and 3 sulfates. And the sulfates cancel out. You end up with your net ionic equation, your spectator sulfate, and then you have your halves. Okay. Single replacement acid. Okay, so solid aluminum plus hydrogen chloride. I mean hydrochloric acid. I'm going to change the acid to its ionic name. So you'll get, so the aluminum takes place of the hydrogen and the hydrogen comes out. So you end up with aluminum chloride and hydrogen gas. And then write out their equations. Al, no charge. HCl, I'm going to write it in its ionic version. Aluminum chloride is Al3 plus, Cl minus 3. And hydrogen is H2. Okay. So, and then you balance the equation. And I'm going to start out with 3 chlorines here. Well, this one gets a little crazy. So you have to go back and forth, but you'll notice is that when you get it all done, you'll end up getting 2 aluminums, 6 hydrogens. Okay, you can just play with it to get it right. Right, and then what has, so this is the balance equation, the ionic equation. Each hydrogen chloride splits apart, okay, H and Cl, and does that 3 times, actually 6 times, okay. So there's 6 HCl's, so they split apart, HCl, 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 HCl. So you have 6 H pluses, 6 Cl minuses. You have 2 aluminum chlorides, and they all both split up into Al, Cl, Cl, Cl twice. So you have 2 Als and 6 Cl minuses and 3 H2s. Your minus charge cancels out. That's spectator, and this is your net ionic equation. Okay. Okay, and then you have your half reactions. Remember, okay, so, alright, so remember this, that the hydrogen is always going to get reduced in the acid reactions. Okay, another acid, single replacement. Okay, you have magnesium plus phosphoric acid. I'm going to change it to its ionic name, hydrogen phosphate. That becomes magnesium phosphate plus hydrogen gas. So you get magnesium. So don't worry if the numbers in front. I'll take care of that in a minute. So, and then you have phosphoric acid. So the ionic form, so it's H plus 3 of them. Why do you need 3? Because this has a 3 minus charge and there's a plus. So don't look at this. You have to write the formulas first before you balance. And then the formula for magnesium phosphate is Mg3PO42, and then hydrogen H2. Now to balance the equation, I started with my negative ion, so I have 2 phosphates here, so I have to put a 2 right here. That's my first step. And then I noticed I needed 6 hydrogens, so I come over here and put a 3 to give 6 hydrogens. 3 times 2 is the same thing as 2 times 3. Notice there's not a 2 here. The reason why there's a 3 here is because there's 3 here. Okay, and then fix your magnesiums with 3. Okay, ionic. So each phosphoric acid has 3 hydrogens come off of it, off of the phosphate, and it does that twice, so you end up with 6 hydrogens, H pluses I mean, and then 2 PO4 3 minuses. The magnesium phosphates, they all split apart, so you have 3 magnesium attached to phosphates, everything splits apart, so you end up with 3 magnesium 2 phosphates. Okay, phosphates cancel out, and here's your net ionic equation. Okay, you're going to skip this one because that's what I just did. Alright, okay, another single replacement non-metal. Hopefully you can follow through. This is similar to one we did previously. Hopefully you'll see how it works. Okay, now this one's a little bit different. This is metal acid. We're using sulfurous acid, okay, but you're going to go through the same process. So you end up with zinc sulfite, okay, so this is hydrogen sulfite. So you get zinc sulfide and hydrogen gas. Okay, it's already balanced. You don't have to do anything to it. Okay, the sulfurous acid splits up into two H's and sulfite. The zinc sulfite splits apart into zinc and sulfite. That's the sulfites cancel out, and there's your rest of your equation. All right, finally, double replacements. Okay. All right, I only got about 5 or 6 of these, I think. Okay, double replacements. The third and number 6 didn't work. Okay. All right, so let's the first one that did work was aqueous silver nitrate. That's because we didn't work because there was no insoluble product. So so this reaction takes place because both of these guys are soluble. Nitrate is soluble with everything, and sodium is soluble with everything. Then you end up getting silver swaps with the sodium, so you end up with silver carbonate and sodium nitrate. Silver carbonate is insoluble, so this reaction does take place, and the sodium nitrate is soluble. All right, so you write everybody down: AgNO3, Na plus 2 of them, carbonate, CO3 minus, both aqueous. Then silver nitrate is Ag plus 2, CO3 2 minus, and sodium nitrate is NaNO3. Right now, balanced equation, I have a 2 right here on the sodium, so I end up putting a 2 on this. Okay, and then I noticed I needed to have 2 nitrates, so I ended up putting a 2 right here, and that makes these 2 silvers, and I have 2 silvers here, so I'm all set. So that's balanced equation. So this one's a little bit different. I didn't start with a negative ion. I had to start with positive ion. So write out what happens when they put in water. Each silver nitrate splits apart into AgNO3, Ag and NO3, Ag and NO3. So you have 2 Ags and 2 NO3s. The sodium carbonate splits apart into 2 NAs and 1 CO3, 2 minus. Okay, the silver carbonate does not split apart, stays the way it is. Okay, don't split it apart. That's because it's a solid. S stands for solid, not soluble. Okay, then you have 2 sodium nitrates, each one splitting apart into sodium and nitrate, and it does that twice. There you have that. And so if you notice, double replacement has 2 spectators, the Na plus and the NO3 minus. And then what you're left over is 2 silvers, and carbonate form silver carbonate. Okay, sorry, this over here. Whoops. Sorry about this. It's aqueous potassium hydroxide with aqueous iron 2 nitrate. Okay, this is soluble because of the potassium. This is soluble because of the nitrate. And then iron hydroxide is insoluble, so this reaction takes place. And I like to box off my insoluble product. So the equation is K plus OH minus FeNO3 2. KNO3, FeOH2. To balance the equation, I have 2 hydroxides here, so I put a 2. There should be a 2 in front of this guy right here. Okay, and then a 2 in front of this guy. All right. What happens when you put all of this into water? This guy splits into 2 nitrates and 1 iron. Each one of these splits into a potassium and a nitrate and does that twice. Okay, and then the spectators. So the K pluses, 2K pluses cancel out, and 2 nitrates cancel out, and the hydroxide and iron are left over. Okay, you cancel out the things that are the same on both sides. And OH, Fe are not the same on the product side. In this case, they're together. Over here, they're separate. They're separate here, together over here, so they're not the same. The potassium is the same over here, and on the reactant side, and the nitrate too. Okay, for double replacement, I just said that 3 and 6 didn't work. Okay, so this one here, aqueous ammonium phosphate plus aqueous barium chloride produces aqueous ammonium chloride. Ammonium is ammonium is the one polyatomic ion that I want you to know that has a positive charge on it. Okay, the rest of the polyatomics that we've gone over have minus charge on it. So barium phosphate is insoluble, so this reaction takes place. So you get ammonium phosphate, NH4 plus, you need 3 of them, PO4, 3 minus. Don't worry about the coefficients yet. I'm just going to go through each formula. Ba2 plus, Cl minus 2. Na plus, Cl minus, they have equal charges, so you don't need to crisscross. And then barium phosphate is Ba2 plus 3, PO4, 3 minus 2. All right, balanced equation, I'm going to start out probably with my phosphates. I need to have 2 phosphates here. So what I did was, first step, let's put 2 in front of here. So I have 2 phosphate. Then I have 6 ammoniums, so I put a 6. So I come over here and put a 6. Okay, and then I noticed I need to have 6 chlorides, so I put a 3 times 2 is 6. It says 3. And you can see that that gives me 3 bariums on both sides as well, so it's balanced. Okay. So again, I usually start with a negative ion, at least try it, and see how it goes, and go back and forth. All right. Right, the the ionic equation, there's each ammonium phosphate splits into 3 ammoniums and 1 phosphate, and it does that twice, so you end up with 6 ammoniums, 2 times 3, 2 phosphates. Okay, each barium chloride splits apart into a barium chloride. So barium, 3 bariums and 6 chlorides. Okay, the sodium chloride splits into NH4Cl minus, and it does that 6 times. So you have 6 NH4s and CX6Cl minus. Remember, double replacement, there's no changes in the charges. Only changes in state. Okay, and then the barium phosphate does not split apart in water. Okay, because it's insoluble. Only soluble ionic compounds split apart in water. All right, and what's left over, your ammonium and chloride are your spectators, and then you end up with this, your net ionic equation. Okay, then a couple acid-base reactions. So you have barium hydroxide plus hydrochloric acid. I'm going to change a hydrochloric acid to its ionic name. So you end up getting barium chloride and hydrogen hydroxide. Remember, hydrogen hydroxide is water, but I'm not going to write it as H2O. I'm going to write it as HOH, because that's going to help me balance it. Right, so write everybody out. You have barium hydroxide, BaOH2, HCl, BaCl2 minus, and HOH. Now the balance equation, you can start out with the OHs or Cl2s. So I have two OHs, so I'm going to put a 2 here. Got two OHs. Okay, and now I have two H's, so I put a 2O here. And that should be balanced. Okay. All right. Okay. So the barium hydroxide splits up into Ba and two OHs. The hydrochloric acid splits in HCl and does that twice. The barium chloride splits into Ba and two Cls. And the water essentially doesn't split apart, just stays water. And so you end up getting these as your spectators. Okay, one of the things about acid-base reactions, you'll always form water. All right, and you'll always form an ionic compound. Okay, this should always be, there always should be OH plus H plus, give me H plus OH, all right? And the coefficients will change, but it's always going to have this as your net ionic equation. Okay, and sodium hydroxide with sulfuric acid. Change to hydrogen sulfate, so you get sodium sulfate and hydrogen hydroxide, or water. Write the equations out. Sodium hydroxide, NaOH, H2SO4, Na2SO4 minus, and H plus. I need two sodium, so I put a 2 in front of the sodium, and then I put a 2 in front of the HOH, give me two hydroxides, and the equation's balanced. And there's different ways you could have done that, but that's how I did it here. Then what happens when you put it in water, the sulfates splits into 2H pluses and a sulfate. Sodium sulfate splits into two NAs and one sulfate. Okay, and then the sodiums cancel out and the sulfates cancel out, and you end up with this. Okay, right. In the last two examples, you end up with 2 as coefficients, but they don't always end up with 2, as you will see here. Okay. Calcium hydroxide plus phosphoric acid can be, so change it to its ionic name. So you get calcium phosphate and hydrogen hydroxide. This is calcium hydroxide, this is phosphoric acid, calcium phosphate, and HOH. Balanced equation, I started out with the phosphates, I need 2. So I'm going to put a 2 here, so that's step 1. I need 6 hydrogens, so I put a 6 here. 6 times 1. Now I need 6 OHs, so 3 times 2 is 6. And if you notice, after you do that, you need 3 calciums, and that's all ready. Okay. Okay. What splits apart? Each calcium hydroxide splits into calcium into hydroxide and does that 3 times. So you end up with 3 calciums and 6 hydroxides. Each phosphoric acid splits into 3 hydrogens and 2 phosphates, and it does that twice. So we have 6 H pluses and 2 PO4s, and then the calcium phosphate splits into 3 calciums and 2 phosphates, and the water is split apart, and so the calcium and the phosphate cancel out. They're spectators on both sides, and then you end up with this. All right, and this is going to be exactly 1 hour of work. All right, hopefully that will help you with your with the problems. Okay, like I said, it's going to be over 1 hour. It's going to be one example of combustion reaction that you're going to have to do. You're going to have to do a single replacement metal ionic, single replacement metal acid, double replacement precipitation, and double replacement acid base. You're going to have to do one of each besides the quizzes. Okay. I'm going to give you about a week to study these problems, and you'll have this test, okay, the second week of October.